All right, well, welcome, everyone. I'm Terrell Russell. I work at iRODS. I'm the chief technologist right now of the iRODS consortium. And today I'm going to be speaking about beyond discoverability. We're going to use metadata to drive data management. So I work at the iRODS consortium. It's a consortium made up of members. Members are users who decide they want this software to exist into the future. The consortium is part of the Renaissance Computing Institute, which is one of 60 or 70 research institutes at UNC in Chapel Hill, North Carolina. So I'm a state employee and work for the university. Our membership right now is 25 organizations around the world. 2 of them are still anonymous, but these are largely people doing science, storage vendors, and then integrators who have boots on the ground. We're not large enough to do global kind of support in place, so we've got people who learn things, we teach them, and then they teach everybody else. So today I'm going to talk about discoverability and then how to get beyond that. So many organizations around the world now have moved from manual pipelines when they're doing their science into more automated systems, and that's good. But they don't necessarily know how the data got to the state that it's in their giant system that they have. They can't make strong claims about it. They don't necessarily have the confidence in their data sets and their pipelines to be able to understand what's in there and where the meaning is. And so we think that to get to that point, you need policy. And if your policy is enforced well, then that model for data governance is what allows you to be confident in what you've got. And so a small treatise on metadata real quick. Metadata can be curated and made by a couple different ways. We've always done it manually in the past. It's done by humans, that's great. It's very rich. Of course, it's very slow, and there's usually typos and things like that. It's inconsistent. We've largely now moved to automatic curation, but that's really good. It's great, it's fast. And it can do things in 2 or 3 different ways. So it can get metadata out of the system that it comes from. It can extract it from the file itself, perhaps, if it's a file format that has some rich formatting inside of it. Or it can be associated with that data from somewhere else, maybe harvested from a different kind of system, where you can start to make connections. So whether it's made by humans or by the machine, the metadata itself can be of 3 different types. It can either be descriptive and describe the thing itself, or it can be structural and describe the format of the data or where it came from, that kind of stuff. And then what we're most interested in now, because the other 2 are largely solved, is the administrative, right? We're interested in being able to describe the processes around that data and that curation in a way that allows things to be automated and fast. So in that worldview, the structural helps to capture and create the descriptive, perhaps, and that administrative metadata is what drives the policy. And once you've got policy, you can get to meaning and actually be able to do some science. In our system, we can actually put metadata not just on the files and the collections, but we can actually put it on the users and on the storage resources and even the zone itself, which starts to contextualize the system and gives that policy engine the ability to make decisions about the data based on the metadata. So with an open, policy-based platform, and iRODS is a C++ client-server BSD3 licensed open source technology. So with an open platform like this, you can take your metadata and elevate it beyond just, can I find my stuff? And you can actually turn it into a tool to help you automate the management around that data. You can then query things and build cohorts for your analysis about the data movement. You can schedule things based on where it is, who touched it last. The state of the world starts to have an influence on where your data goes. That gives you a strong assurance around the data governance, which means that you can make strong claims later about what's going on. So we think that data management should not just be a descriptive, it should actually be data-centric and metadata-driven. And if all that's true, only when that policy is automated do you actually get the confidence and that integrity and the provenance of where things came from and that enforcement of quality metadata so that you can assume that there's no typos, it came in consistently, and you can actually do the science in a way that is reproducible, which frankly is the only way that you can actually do science anyway. And our point here is that if you leave the people in the loop for this, it's going to be a mistake. They're going to make, it's not going to work. You're going to lose the confidence in the system. People are really good about making decisions and thinking about things. And so you should let the people have meetings and craft the policy that the computers should be the one enforcing. So iRODS is the building blocks for all of those kind of things. With that policy automation, you can make these kind of decisions better. So the next few slides I can go through very quickly, but our big picture here is that we have a data management model. We have abstractions around storage. We have a metadata catalog. And we have a policy engine that can allow you to do this arbitrary definition of policy and enforce it in an automated way. The use cases that we've seen across industries in the last 2, 3, 4 years are all a subset of these 8 capabilities here on screen. Everything that we've heard is some piece of all of this. You don't have to do all of it at the beginning. Most people show up because they either buy a new company and they now have lots of different types of storage in different places and they want to unify it. But eventually they are interested in the auditing and the compliance piece, the provenance piece. They want to make claims about what's in the system, and we allow them to do that in a good way. We do this with 4 pieces of infrastructure. We abstract the storage, we provide a catalog, we provide a rule engine, and then because the system is open source, it can federate with other instances of itself, which means that you can collaborate with people in other organizations that you have not yet even met. And then when you're done with that collaboration, you can tear it down again, but everybody's equal. When somebody's in your world, your policy fires. If you go over the bridge into their network and their stuff, their policy fires. Above that, here are the policies that we've seen in the wild and we've written and implemented. Not everybody needs all of these, that's fine. But when you combine some of these together, you get these 8 capabilities that were on that earlier slide. The nice thing about this is that now these are packaged and supported solutions. So if you want to do storage tiering, you don't have to write your own code and figure out all the crazy edge cases. We've done that for you. We provide a packaged solution, and you have the configuration and the knobs to turn to make it easy for you. If you want to do the same thing with auditing or automated ingest, these are now just knobs that you tweak for your existing infrastructure. I've got some examples of some of these. This is a one-pager on storage tiering. We've got a one-pager on automated ingest when somebody else is the source of truth and you want to keep iRODS up to date. We've got one for automated ingest in a different mode for maybe you've got microscopes or satellites dumping data somewhere and iRODS is the source of truth, and then this can manage it and move it out of the way once the originals are no longer needed. We've got one around indexing, arbitrary indexing technology that you may already have. We can speak to it. Same thing with publishing. If you need to put things on the internet and put DOIs around them or talk to the library, then we can handle that. And then here's the thing where you want to make strong claims about what's happened in the system. So a full audit trail can go out to engines that already exist in your infrastructure, and then you can operate on those events and produce reports in a granular or aggregate way. We've seen patterns when people stitch all this stuff together. Largely, at this conference, people are most interested in the data to compute model. They have a giant computer they've paid for, and they want to use it for their science. Or the opposite, where the data's too big, and they want to move the science to the data. And then we've got patterns around synchronization and, more recently, a data transfer nodes. So this is with the big computer in the basement. You can now just stage it out, do the science, trim it off, and it's all fully packaged and managed and handled by the policy engine. This is the opposite. It's already in place. It's heavyweight. You can't move it. Instead, you can send the Docker containers or whatever it is over to where the data is, compute in place, and then register the results. It's still all in the same namespace. This is if you've got things that are changing in multiple places. This system will track and keep things up to date. We can go across cloud. We can go on-premise. It doesn't matter. Different types of technology, tape, fast disk, slow disk, whatever you want. And then this is the last one we've done most recently. We provide a surface for collaborators or your other big computer that doesn't speak the iRODS protocol. It's a REST interface now. And then this allows a controlled way for ingress and egress to partners that you may need to work with. And all that's based on the same core set of technologies, and it's just a matter of how you stitch them together to meet your needs and your use cases. So the claim here is that data management should be data-centric, always, but we are making a stronger claim that it should be metadata-driven. You can turn your metadata into being prescriptive metadata and actually drive the policy itself. And if you're going to do this well, we think the right answer to be future-proof is to do it in open formats and with open source code, because your stuff is going to keep changing, different people are going to be in charge, and this is the way to prevent that from mattering in the future. Thank you.